We've already seen how to compile a .NET Core application using the .NET build command. However, I want to spend some time talking about this process as well as deployment in a bit more detail in this lesson. There are two ways that you can deploy your application from your developer or your build machine to a target client computer. So you can deploy either as a portable app or as a self-contained application. So in a nutshell, a portable app relies on the .NET Core already being installed on the client computer. It'll use the shared system-wide version of the .NET Core to execute the application. So you only deploy the assembly, the .dll file, plus any other third-party dependencies that are not part of CoreFX, like newtonsoft.json, for example. All right. So assuming your application is called Hello World, like in our case, then you would deploy the hello world.dll and then newtonsoft.json.dll. Now that is a portable application. A self-contained application doesn't share anything with the rest of the client computer. In other words, in addition to the app files, so the hello world.dll, the newtonsoft.json.dll, those third-party dependencies, then you install the .NET Core itself specifically for that application. So in other words, Hello World would get its own .NET Core installed along with it on the client computer. So the .NET Core is actually then renamed to match the name of your application. So if your application name is Hello World, then on a Windows system, the application would be named helloworld.exe, and you would also then have the helloworld.dll, which actually has your program code. So the core helloworld.exe would then use the helloworld.dll, your code, plus the newtonsoft.json.dll. All right, so that's the difference between portable apps and self-contained applications. So the benefit of a portable app is that you don't have to decide up front which operating system to target because it'll work on everything as long as the .NET Core is installed on that client computer. Furthermore, the package size is much smaller, as you can imagine, because you're only deploying your own code, not the entire .NET Core framework. So on the client, they save disk space because all portable apps will share the same .NET framework, Core framework install. Now the disadvantage is that the exact version of the .NET Core must be installed on the client operating system in order for this to work. So if you're targeting in the future, let's say, .NET Core 1.1, but the client computer only has 1.0 installed, then your app won't work. Furthermore, it's possible that dependencies in the CoreFX library, for example, will change, and if your app relies on the features that have changed, then it will unexpectedly quit as well. So let's talk about publishing a portable version of your application. To do that, we're going to call .NET and then publish, and then I'm going to use the F argument, NetCore app 1.0, and then the C argument for release. So the -F is the targeted framework. So I'm giving it what's called an FID, or a framework identifier, NetCore app 1.0. All right, and if we don't give it this, it'll read it actually from the project.json, but I'm going to go ahead and supply it as an argument, as you can see here. And then the -C is actually the configuration. So it's either going to be debug or release. And this is optional as well. If you don't supply it, it'll just be a debug version. But we're specifically creating a release version. So now let's go ahead and click enter, and you can see everything that happens here. It's compiling Hello World for the .NET Core app version 1.0. The compilation succeeded. Then it's publishing it to the Hello World bin release NetCore app 1.0 published directory. So let's go in there real quick. cd bin, cd release, cd netcore app 1.0, and then let's do a directory, and you can see that we have pretty much all the same files that we had previously in our debug folder. All right. So along with the application file, this hello-world.dll, the publishing process will emit this PDB, which is a program database, and it contains debugging information about your app so that a debugger like Visual Studio can hook up to it and can run it in debug mode. Of course, you don't need that if you're providing a release version. But the file is also useful for things like debugging exceptions, but you can choose to just not package this and not provide it and give it away with your application. But basically, I can take this whole thing and I can zip it up. And actually, I think I need to go one more level deep, don't I, to the publish directory? Let's go to publish. And I'll see the directory there. All right, yeah, this actually has what you want to take up and zip up and then provide this. And if you unzip it on a client computer that's running the .NET Core Framework 1.0, doesn't matter if it's Linux, Mac, whatever, it will run this application. Again, it's portable, so the .NET Framework Core 1.0 has to be installed on that computer. But everything in this publish directory would go along with it. You can see that it has its own copy of newtonsoft.json.dll, as well as some of the dependencies like system.runtime serialization.primitives that are needed by newtonsoft.json.dll. Okay. Now, optionally, I could create an installer. However, I would need some third-party tool to do that. It's not included in .NET Core 1.0. That's really outside the scope of this because, frankly, you'll probably never do that with a console window application anyway. So that's how you work with portable applications. What about self-contained applications? So we've already talked about the benefits and disadvantages of portable apps and compared them to self-contained applications. So I'm just going to jump into right now how to actually create a self-contained version of our application. Let me go ahead and get back to where I was, back in the Hello World directory for starters. And first of all, what we need to do is actually modify the project.json file, and we need to remove the type platform attribute that indicates that the framework is provided as a set of components local to our application rather than as system-wide platform package. So we'll go notepad project.json, and I'm going to actually remove this right here. Okay. So again, by removing that, we're saying, hey, don't rely on anything outside of our package that we're supplying inside of this self-contained application. All right. The second thing that I need to do is add a section here that will target a specific runtime. So these are the operating systems that I want to use my application on. So what I'll do is actually right after this section right here, we're going to create another part right here, and it's going to be runtimes. And here we're going to go and use some identifiers that I know because I have them in my notes. So basically we're saying we're going to target Win10 on x64. We'll also target OSX.10.10 on the 64-bit architecture as well. Okay, OSX 10.10-x64, that should work. So let's save that now. Great. And then what I'm going to need to do is I'm going to need to build, or I'm going to actually need to run .NET restore. This will then restore the dependencies to the project. This is necessary since we're going to need to pull down a bunch of operating specific assemblies for low-level operations, specifically for OS X. Now, I provide a screenshot in the text version of this of what happens when you don't already have the assemblies. It actually pulls down a ton of assemblies for both Windows and Mac. I'm not going to do that here because I've already done it on this local computer one time. But if you were to run that on your local computer, you might see like 20 or 30 entries of NuGet grabbing down packages specific to compiling to those two platforms, Win10 x64 and OS X or OS 10 x64 as well. All right, so now that we've done that, we're going to need to use the .NET publish command, and we're going to need to give it and say, I want to do a release, and specifically, I'm going to use the R flag here, and the R is for the runtime that I'm targeting. And so I'm going to do this twice. The first time for Win10, using that same identifier that I used before, what we're calling the runtime identifier or RID. I'll show you where you get those in just a moment. And so it published the first one to the release netcore app Win10 x64 publish folder, and then we'll do it again then for the OS X version that I want to create. So .NET publish, we're going to do a release configuration, and we're going to pick the runtime OS X 10-x64 like so, and it will create those files as well. Now what we can do is actually go into those directories. So let's go cd bin cd release, and now we should have cd netcore app 1.0 app 1.0. Okay. All right, so now we have not only the publish from what we did previously, but now we have the Win10 x64 and the OS X 10. So let's go in and take a look at cd Win10 x64, and we have now a hello world.exe, which again is just, as you can see, is quite large, 127 megs, or is it, I'm sorry, 127K, and that will contain the .NET Core. And then our application itself is only 5K. It's the hello world.dll. That's the code that we wrote. All right. And then obviously, hold on. Actually, we need to look at the publish folder. I apologize. Forgot about that again. Now let's look at this. Okay. Now you see that what's going to come along for the ride are all of the DLLs that we rely on inside of the .NET Core app framework. So this is everything from mscore.dll to newtonsoft.json, all the system dots that are required and so on. All those will get published now onto that end user's computer. Let's now switch and cd into osx.10.10-x64, and let's see what we get inside of there. And let's go in the publish directory and see that. And we get a ton of DLLs as well. However, there's a bunch of these libs, libclr JIT, libcore CLR, lib. And if you notice, these were not part of the previous, I don't think. Here, I might. No, they weren't. And so those are specific to the Mac operating system. Okay. But then there's a lot of these core effects DLLs that are going to be cross-platform. All right. So you'll notice that I used two different runtime IDs, and you can find the list of runtime identifiers from the RID catalog on this URL that you see on screen right now. And so here you see an RID graph. So this will allow you to see that there are packages that contain other packages, and so you can say, hey, I want to target anything, or I want to get very specific to Win10 and a specific build of Win10, 1511, for example. All right. And here are the Windows 7, 8, 10 Linux RIDs and the OS 10 RIDs that are available. All right. So you would use those in order to create your self-contained applications that are specific to those particular platforms. All right, so let's wrap up by talking about some key takeaways. We have two options whenever we're building and packaging our .NET Core applications for deployment. We can either build a portable app or a self-contained application. Portable apps utilize the shared install of the .NET Core on the client computer, but it comes with some potential hazards. Should the version of the .NET Core on or one of the Core FX library dependency packages be incorrect, then your application won't run. However, the other option is to choose a self-contained application which contains the entire .NET Core and the Core FX that come along with the program files that you built and any third-party dependencies, and then you're installing that whole big mess on the end user's computer, which takes up a lot of space, can be a lot larger significantly for downloading, but the beauty of it is that it should always work for that particular targeted runtime identifier. All right, so that pretty much wraps up what we wanted to say. We'll talk about next steps in the next lesson. We'll see you there. Thanks.